Okay, so yeah, welcome. Good morning, and yeah, welcome to our talk. We will talk today about our offline first order platform, which we built at Fondorf for our B2B partners. And yeah, I'm Till. I'm responsible for the digital products at Fondorf, and with me on stage is Philipp. It's my front-end lead developer. And yeah, I will start the presentation and give you some background information why we built this, and yeah, then I will hand over to Philipp, and he will show to you like how we build it and give you some technical insights. So who are we? We are we are a Cologne-based company. Yeah, I made this little chart to give you some insights. Yeah, what my friends think what we do is like we are building a big new company building in Cologne-Ehrenfeld. Yeah, what my mom thinks what we do is like saving the world. So we are a backpack manufacturer, and yeah, our backpacks are made of recycled PET bottles. And yeah, that's why my mom thinks that yeah, we save the world. Yeah, what did the media think? Like these are the three founders of Fondorf, and yeah, that was on a, yeah, after they won a prize on the Deutsche Gründerpreis, and we also won the Nachhaltigkeitspreis, and so on and so on. And yeah, what did my bosses think what we do is, yeah, it's a picture of our last company-wide workshop, where we like build our company culture and yeah, develop it further and further. Yeah, what I think what we do is like coding all day and night. So yeah, that's what I think. And yeah, what we really do is like building backpacks, and so we started 9 years ago with a brand named Ergobag, and then we developed more and more brands. Today we have like 7 brands, from baby to business. For really little child in the kindergarten, we got Affenzahn, and then Ergobag, Sedge, maybe you know Ever or Ping Pong. This is also some of our brands. And then we got Salzen, it's a business backpack brand. Yeah, that also belongs to our company. Yeah, what was our challenge? What I'm talking today is like every of our brands has 1 or 3 collections every year, and yeah, in this fast, you like our sales representatives, sorry, go to yeah, they have a really strong relationship to our retailers, and in the yeah, they drive to the retailers and coach and present the new collection and the new products, and then they also made a pre-order every year. So the yeah, every sales representative make 1 to 2 pre-orders per year, and so we at Fondorf we have like 100 sales reps, and yeah, 100 orders per year in total, and it takes like 2 hours per order for a sales rep on the presentation. So in total, it's like 20,000 hours of work, and that's a lot. Yeah, that's our current B2B shop. Yeah, it looks like a little bit like an Excel sheet, but it's not. And yeah, you can see like it's a really big product grid with different columns for each delivery date. We know of each delivery date, we know the exactly stock information. Like the sales rep can order those different products from here, and then go to the checkout step, and yeah, order the products. Yeah. So we got at the current point we got 3 different customer journeys. The first journey is like the sales rep directly uses our old classic B2B shop. At the moment, it's not offline ready, and so if there's any problem at like, for example, if the Wi-Fi stops working and the sales representative is yeah, by the retailer ordering, it's really like frustrating, and yeah, it's really painful. Yeah, then we built a workaround for this, like the sales reps like order into an Excel sheet, and then they drive home and retype everything into our B2B shop, order again, and yeah, but this is like, yeah, really like this cat, like really retyping, really time intensive. It's yeah, also really painful. Yeah, at the next, then we built a workaround for this, like the sales rep order into the Excel sheet, then we built an Excel upload, and then they can like yeah, check out in the B2B shop. Yeah, but all of you may know Excel, and you might not know our sales reps, but yeah, they do the crazy things with Excel, and yeah, like hiding columns or deleting columns, switching some informations into the tables, and yeah, Excel upload really don't work for us. And yeah, it's really high maintaining costs and high yeah, like service and support for our development team. Yeah, this is like a conclusion of our like pains at the moment or in the past. So yeah, it doesn't work if there's no internet or slow internet connection. It's really time consuming. It's really frustrating for the sales reps if an error occurs. It's really support intensive, and yeah, individual prices, like if you have only one Excel sheet for all your customers, are not possible. And yeah, what's also not possible is individual availabilities into the Excel sheet, because then you have to like update your Excel sheet every day. This is also not possible. Yeah, and Excel, yeah, really doesn't work out for us. So we came up with a mission for our new shop, our new project, and that was like building a reliable, fast, personalized app for yeah, with the old well-known experience. And yeah, that's it. And now we'll hand over to Philipp, and he will give you some insights yeah, about our product.
Thank you. Hey everyone. So yeah, basically we try to capture the order process in some kind of customized Excel sheet. There's an upload, and this is really kind of buggy. It doesn't really work well, and no one's happy about that. So we sat down and we thought about how to go forward and rethink this process and do something that our sales reps are familiar with and that they will see and understand. And because they use Excel a lot, we piggybacked onto the spreadsheet idea and presented our order experience as a spreadsheet. This is the new order experience. So far, we built this from the perspective of only one user group, which is the external sales representative. So this is basically a sub-app under a big platform ecosystem. And yeah, right. This is the thing we built. You see, it kind of looks like the old one. We kept the queues of like the big order grid. You know, it's a data grid. There's lots of rows of products. It's nothing new, but we put our own little spin on it, and we integrated the spreadsheet idea into the whole thing. So you see on the right, there's a column. The name is immediately. That's kind of not the right name for it. We're changing this. This is just translated. You can think of it as like ASAP. So basically, if you want to order something and you want it as soon as possible, this is the column for you, because this basically resolves to whenever we can give it to you. That's it. And if you actually know the delivery date and you have like, you want to plan for the future, sorry, you want to plan for the future, you can go and add multiple delivery dates, and they will be added as a column. So you can plan your deliveries and your amounts accordingly. Right. So I'm not sure. I'm kind of new to e-commerce, so I'm not sure if this is new, if this is a special thing. But we have a very granular tracking of where our shipping containers are and when they will arrive, and we can project how many products we will have in the future based on that. So if you add columns with delivery dates, you will get information about will these products that you're requesting, will they be there on that date? Can we do that for you? So if I put some in here, you can see there's some kind of like selection rectangle, and it already kind of is reminiscent of some spreadsheet you can navigate around. And you see that you get some contextual information. On this, like everything is fine, and you can put in your 123 products. But if you go overboard, then you get information that this is not going to work. And you can see that if I go back, the checkout button in the bottom right corner is going to be grayed out as soon as you have some kind of validation error. We allow you to put anything in the cart. The cart can have like it's basically valid or invalid, and we don't let you through when it's not valid. So you need to clean up your errors. Right. And now I went and copy-pasted something. So I went up to the top left cell and hit Command-C. And then I like dragged up in a selection, and I'm not going to paste whatever I had there in there. And that is already, you see that this is the spreadsheet approach. We have lots of editable cells. We can navigate around. We can make selections. And this is going to help our sales reps and customers to prepare their orders better. So when you know you have like this block of order data and you need it repeatedly for the next 2 weeks or something, you can just copy paste that over. Right. And you can see that there's a contextual highlighting in the cells that tells you that we can't provide this amount of products on this date, or there's going to be some other error. If you navigate onto the cell, it's going to tell you. And yeah, everything updates in real time, and it gets synced back to the server. Right. And then this is the last step. Basically, I cleaned up the ones that don't work, and the cart is valid again. And that's it. I'm going to tell you a bit about our tech stack, and we picked out some little interesting nuggets that were challenging or interesting for us. Basically, our backend is Spryker. This is currently not even true. Like, we are running on Magento, but we are switching to Spryker. Spryker is a modular and API-first e-commerce platform system that we are currently building up. And just compared to Magento, we have a lot more flexibility, and it's a lot faster, because in Magento you basically talk directly to the database, and it's really slow. It's not very great. Spryker offers you a lot more caching layers, and it's very, very fast and very smart. Right. And since this is e-commerce, there's lots of like different backend systems. There's, you know, the ERP and whatnot. The Spryker API combines all of these data streams into one API that the front end uses. Speaking about the front end, it's React. I'm not sure if you're familiar with React. I'm not going to go into super huge detail about it, but React kind of turned the how you build web applications with JavaScript on its head. It's a very declarative approach to programming. Instead of telling this element on the page to do a thing, you know, update your counter when the amount of products changes or something, you just describe what you want to be. You say that, like, there's a counter and I want it to represent the amount of products, and if it's over 100, then I want to shorten that to 100 and plus. And you don't have to go and like update the text content, but React takes care of that for you if you just describe what you want it to happen. Right. And React is extremely flexible. It is intentionally not a framework. It is basically just a UI renderer. And it's the flexibility and the speed and versatility allows us to build our own custom experiences without relying on big external systems. And it's extremely lightweight. And you can compose stuff on top of each other. And there's also lots of developer happiness. You keep people around. React is great. People like it. and it attracts talent. Right, so the product grid that I just showed you, we had an immediate challenge that rendering long lists is really slow. And because we want to be offline, that basically means that we need to download all of the product data that we have and cache it in the browser and then display it and filter on in the client, because we want to be able to do that offline. And that results in really, really long lists. Like, I think there's like 5,000 products right now, and it's going to double soon. And even though we're using React, React is not magic. And if you put like a really complex list into the DOM, it's going to be slow, and it's going to be very long, and it's not great. So, very long lists. If you render thousands of complex rows, this is going to be intensive and slow, but you're never going to see all of these thousands of rows at the same time. And you only really need to render what the user can see. So why render it? Why do anything? So this is where virtual rendering comes in. Virtual rendering is not specific to React. It is really something that the browser should do, or at least, I mean, it does that, but it doesn't allow you to customize that experience and influence it. So basically, you can't tell it that like these thousands of rows that are there somewhere below the fold that you can't see, they're not important, and that doesn't work. So basically, the idea is that you have some kind of scrolling container, whether it's like the actual page itself or some kind of subcontainer, and it scrolls and it's going to obscure or occlude whatever is outside of it. And whatever's outside of it is not important, you don't want to render it. So there's a package that's called React Virtualized, which implements all this stuff for us. That's really nice. And basically you hand it your list of items, you tell it how to render an item, and it will figure out the size of the containing container, and will then only render what is necessary. There's a couple of specifics that, if you really are interested in how that works, I could answer it later in QA, but this is kind of the gist of it. And there's a handy-dandy animation that I stole that kind of shows how that works. So that was challenge number one. And number two is that we really wanted the spreadsheet experience, but we needed something light. And if you look into the space, all the prior art is not light at all. Everything is heavy. There's lots of like professional grade data grids. They do formulas. They will do their own virtual rendering, which is not always compatible with what we do. And also, it tends to be that you have the full Excel experience. That means you have editable cells everywhere, and you can't really restrict that. And what we really needed is like a subset. We just needed a couple columns that are editable. So because React is composable, and we can just build abstractions on top of each other, we just built our own. And it wasn't even that hard. Basically, I'm going to speed through this a bit. Cell selection and navigation is completely external to the virtual list rendering. So this like React virtualized thing has no idea that it's being used as some kind of Excel-y spreadsheet thing. That's really great because we don't have to couple anything, and it doesn't have to know about that. And cell selection itself, the selection state is just stored as 2 points. We have P1 is the top left, and P2 is the bottom right. And as like the default, if there's like just a single selection, both of the points are on the same point. And we call that one-dimensional because it doesn't create a surface, basically. But selection can become two-dimensional as soon as the points diverge. So the user clicked somewhere and then dragged the selection open. That means he sets the first point, and then like the second point wanders. That also works if you hold like Shift and use the arrow keys and stuff like that. And this is a really lightweight representation of selection state and cells in itself. And yeah, that was really not that much. And then we come to rendering. Because the virtualized list renderer doesn't know that it's being used in this context, we need to pass down the selection state onto the columns and cells. And we have the special column that is our actual like amount input for the amounts that you want to order. And they receive knowledge about where the cell selection is and whether they are selected, whether they are inside a selection or touch the edges, and style themselves appropriately. So basically, it's just a big like collision detection kind of thing, where the cell knows where it is inside the selection and reacts. And right, the Y position of the leading selection, basically when you click down and drag, or you hold shift and you move the other point around, that's the leading edge. And this thing drives the scroll position of the virtual list renderer. So everything is always in sight and you can see it. And that's it. That's really everything we needed. Right, and then like commands. Of course, we don't want to build a full Excel. That's way too much stuff. It's way too intricate, and we don't really want to replicate all of that. But we need to provide some level of fidelity to make people understand that they can use it like the thing that they're used to. So we try to like really hold back on that and don't do too much because it's a really big surface of commands and potential bugs. So basically there's the modal editing mode, so you can navigate around the table, and you can also navigate around the actual input when you're in an editing state. That's just one. And then we have a copy command, which really just marks the current selection points as the source selection, and then stores that. And whenever a paste command occurs, then we override the data that is in the destination selection with the stuff from the source. So that's really it. We also, I kind of lied, we also actually store the values that are underlying this whole thing to be able to paste that into external applications at a later point. But that's the gist of it. Right. Last challenge, making it work offline. And the fun part is that we don't have to do that much, not yet. Service workers are a cool thing. They are fairly new, but already work really well. So whenever you have a web page, say you have a big, long web page and there's an image somewhere below the fold, and you scroll, and the browser sees, okay, there's an image, and I need to load that. So it makes a network request with for the image data. And the service worker sits between the page itself and the network, and will be able to see that there's a request coming in for image data, or for this specific resource. And when you build a web app, you have certain assets that are included in the app. So you have like a background image or an icon or something like that. And because we know that these exist and we know that these are there, we can build a manifest file on build. So there's a manifest file that lists all of the things that should be included with the application, and the service worker is able to preload all of that on the first time it loads and caches that in the browser. So whenever it occurs that the page requests a resource that is known to the service worker manifest, it will intercept that and just give you whatever is in the cache. And that allows you to do offline stuff. Because this doesn't only work for images, it also works for entire HTML files. So if you have like the index HTML where your app lives, this too can be served from the service worker cache. And that's really cool. And so we get basically most of the offline stuff for free. So you can, like, if the external sales rep that we support, he sits like with the customer, and this being Germany, there's no free Wi-Fi everywhere. They sit somewhere like in the Teeküche somewhere, and it's not great, but they can just load the app because it's already preloaded and pre-cached in the browser. They can open it, they can put in their stuff. They of course don't get all of the fidelity that they would get if they were online, so we can't live check the availabilities for whatever they need. But we have some idea, we have some like pre-cached stuff from there as well. And yeah, that works. So The second part is the actual interaction with the API. And I just mentioned that if they sit there and they put in their data, that works. Everything is just done locally inside the application. And as soon as network connectivity returns and they go home or to their hotel or whatever, then like all of the changes will be synced to the server and they can do the final order, basically. That's it. It's kind of maybe too soon, but I forgot to say that basically this is the first step. We are going to build this out as a platform. So this is like the first perspective of the sales rep, but there are a lot of different users that need to do this kind of stuff. There's like internal customer support, there's external customers, there's all kinds of people, and especially like customers of customers and all this kind of stuff. And we are going to expand this and treat it as a platform. So what you just saw, the application is going to be a sub-application in this whole ecosystem that gets loaded on demand. And we will have lots of other stuff like administrative things like a CRM or like an event manager, and all that kind of stuff is going to be in there. Yeah, that's it, I think. Thanks for listening. Any questions?
When you're offline, how do you deal with the user authentication?
Of course, we can only let the user use the stuff if they're already logged in. So we have the user logs in and we cache their details in the browser cache. And if they have already authenticated, they get to use the app. If they don't, they can't. That's
okay,
it.
so if you don't authenticate before you go offline, you can't work it. Okay.
Exactly. Up
there. One question, please. So you make an API request to get data you want to show. How do you store it in the browser? Do you use some kind of PouchDB or something like this?
We use local forage. This is a Mozilla-backed endeavor. It basically wraps local storage, and if available, it also does the indexed DB and stuff like that. And I think the browsers we target all do indexed DB. So in the end, it's going to end up in an indexed DB, but that's kind of a technical detail.
And on the backend side, you have a text database or relational database like MySQL or something?
It's a MySQL database.
Okay, okay. Thanks. One more question. What are the biggest data sets you have to deal with?
Oh, that's the product data, basically. I think currently it's like 5,000 products, and they're fairly big. So we are, I think, currently the application takes up like 18 megabytes or something, just in cache, like just data cache. And it's going to be more at some point. So we need to, at some point, also look at like compression strategies and how to manage all the data that we need to save. Because if we truly want to be able to use this thing offline, then we need to save lots of stuff to actually like show something that makes sense. Especially, I forgot to mention that we have we have different price ranges for different customers. So whenever you create some kind of cart, you say you want to do that for a customer, and then we just load the price data for that customer. And because this needs to happen and needs to work, we store all of these different price ranges separately for each customer. And so whenever you can just create a new cart when you're offline, and if we already have that data, then that works. And if we don't, then you're out of luck.
And how is the performance of IndexedDB? I think it's synchronous only.
No, it's very async. This hasn't been a problem so far. The performance of the underlying caching system is pretty good. The most problem we had actually was when our like debugging and development tools have to display lots of data. They kind of get wonky, but that was it basically.
And do you just do some kind of compression of the database, like gzip on the fly?
I'm not sure what IndexedDB does. We don't do anything special.
Okay.
We didn't have to yet, but we are looking at solutions. There's basically like full databases that just run on JavaScript inside the browser that you have more control over than, like, say, IndexedDB. But we didn't have to do that so far, but we'll get you.
Okay, thank you.
Alrighty, then, thanks for coming.